A very, very good morning, all. A warm welcome to you all for the second day two Atal sponsored FDP on Green Technology for Sustainable Life Indian Perspective. Today we have Dr. Srijit S. Assistant Professor from NIT Silchar to deliver a lecture on G2V and V2G technologies in electric vehicle. I welcome you, sir. A brief bio about him. Dr. Srijit S. graduated in Electrical and Electronics Engineering from NI College of Engineering, Kanyakumari. He obtained his Master's in Power Electronics and Drives from MS Engineering College, Shivakashi. He did his full-time doctorate at NIT Trichy on the area Power Electronics Applications to Power Systems. Presently, he is working as Assistant Professor in the Department of Electrical Engineering, National Institute of Technology, Silchar. Before joining NIT Silchar, he worked as Associate Professor, Energy and Power Electronics Department, School of Electrical Engineering, Vellore Institute of Technology, Vellore. He is having more than 16 years of teaching and research experience. He has published more than 50 papers in referred international journals like IEEE, Elsewhere, Springer, and international conferences. He is a reviewer in IEEE, IET, Elsewhere, Taylor and Francis, Springer, and lot of other journals. He is serving as editorial board member in few journals. He has given a number of lectures and hands-on training on power electronics, power systems, drives, FACS, and HVDC smart grid. He is member in board of studies in various institutions. He is guiding a number of BTech, MTech, and PhD scholars. His area of interest are power electronics, power systems, renewable energy sources, drives, smart grid, optimization techniques, FACS and HVDC, electric vehicles. It's privilege to have you, sir, with us today. Once again, welcome, sir, for Atal FDP. Thank you. And over to you, sir.
Thank you, ma'am. Shall I share the screen, ma'am?
Yeah, yes, sir.
Hello, Shopra ma'am.
Yes.
Yeah, this is Dr. Adhikari from Bangalore.
Yes, sir.
Actually, I was having some network issue yesterday. I was logged in, but the chats and all I was not able to see. So was there any attendance yesterday?
Yeah, we are taking directly from the WebEx attendance.
Oh, okay. Then it is okay because I was not able to access the chat box.
Okay.
But I was logged in, means my name was showing in the WebEx.
Yeah, then it will be recorded, sir. It's not
okay.
at all a
Thank
problem.
you so much, ma'am. Have a nice day.
Yeah, okay. Thank you. Wish you same. Yeah, sir. Shall we start, sir?
Shall we start? Yeah, ma'am. Okay. Thank you, Swapna ma'am, for your introduction. And a very pleasant morning to all. Today, we are going to deal with electric vehicles, grid to vehicle, and vehicle to grid technology. Yeah. Okay. So if you see the contents which we're going to discuss, we'll start with the basics of electric vehicles. Okay. So we need to know why we need to, what is an electric vehicle, why we need to go for electric vehicle, right? So those things we'll see starting. Then we'll see there are a lot of issues with the existing IC engine based vehicle. That means they're running in fossil fuels. So we'll see what are the issues with fossil fuel. Then we'll see, once we see the introduction about electric vehicles, then we'll see what are the major components in electric vehicle. Then we'll just list out a few components of that. Then we'll see what are the types of electric vehicle. All these things will be discussed with respect to grid to vehicle technology. And then we'll go on to the next topic, that is demand side management. That means if you want to understand what is a vehicle to grid, that means you are pumping power from vehicle to grid, then the basic understanding of demand side management is needed. So we'll see a simple definition of demand side management. And finally, we'll end up with vehicle to grid technology. So these are the things which I'm going to discuss in today's session. So let's start with a definition of what is an electric vehicle, right? As you know, right, this is the word which mostly pronounced nowadays. And a lot of researchers are working in this area. You can see lots of journals, a lot of projects, a lot of things are there in this area. Okay, so if you see electric vehicles in general, the basic difference, if you're saying, if you see the drive, okay, when you're going for a IC based vehicle, the drive is an IC engine, right? That you all know that, right? Whereas when you come for electric vehicle, the drive is an electric motor. So that makes a big difference, right? IC engine based vehicle, the drive is an IC engine. Whereas when you come for an electric vehicle, it's a motor. Then if you see the source, okay, as you're using IC engine, will mostly will use fossil fuel, right? Either it can be petrol or diesel or it can be gasoline. Okay, whereas we are using electric motor for EVs, so obviously the source will be of electrical energy, right? So it can be of anything, fuel cell or battery, whatever it is. So this is the major difference. The drive is different and the source is also different. Okay. But before going into what are the types of EV, all such things, let's see why we need to go for EV. Okay, so I'll just list out the points, then let me explain what it is. Okay, so for example, let me take one example. Okay, so let's take customer, let me take myself. Okay, one side I have an IC engine based vehicle, other side I have an electric vehicle. Okay, so if I'm taking IC engine based vehicle, they're readily available, right? If I want to buy a new two-wheeler, okay, it's readily showrooms, a lot of showrooms are available. You can go there, you can pay money and you can get it. That means they are easily available. Okay. Then if you want to fill fuel for, if you see cities for each 500 meters, you can go see a petrol bank, right? So getting a fuel is also very easy and it takes a maximum of 2 to 3 minutes, right? If you have a lot of people there, then 10 minutes. That's the maximum we can will be taken to fill the fuel. So fuel availability is there. We can easily fill the fuel. Okay. Then another thing is if I face any issue with this vehicle, then I can easily take to a service station because you can see, right? If you take 1 kilometer, at least you have 2 to 3 service centers in between. So it can be easily serviceable. So you can, they are readily available. Okay, filling fuel is easy. Okay, then if any issues there, I can easily service it. And if I want to get more comfort, then I can go for the next version. So on one side, as a customer, if I'm seeing, I'm okay with the IC engine based vehicle I have. Okay. Well, let me come to the next side as electric vehicle. Okay. See, availability is not that much now, right? I'm telling about now, right? We don't have that much showroom for that. Okay. So availability is restricted. Then the cost, that's a very important factor. The cost of initial cost of electric vehicle is very high as of now. Okay. So if we compare the cost also, EV cost is much higher now. Then another important factor will come when you're going to fill the fuel. Okay, so if you are going to fill the fuel, and if you see the number of service stations there, it's very less now. Okay, we need to find the charging stations. And if you go to a charging station also, it's not 1 minute or 2 minutes or 10 minutes, right? That depends upon the charging you have. If you go for level 1 charging or level 2 charging, it takes hours for charging. Level 3 charging, fast charging, it will take around 1 hour to go for some 80% of the charge. So just see one side, fuel you can fill within 10 minutes. Here, just you need to wait for 1 hour to charge your battery. Okay. Then when it comes to service, okay, not everyone can open your EV, right? Because we can't go to roadside service stations and service your EV. We need to go exactly to the service centers and we need to service it. Only the trained people can open and service it. So just see one side, I have an IC engine based vehicle which is readily available, which is of low cost, fuel is easily available, you can fill it, servicing is easy. As a customer, I'm happy with whatever I have. If you go for this side, it's a new technology which is coming, which is not readily available. The initial cost is very high. If you see the fuel, getting a charging station is very tough. You need to find it, you need to locate it. And another thing is that it takes more time to fill, fill fuel in the sense charge the battery. And servicing is also not readily available. So as a customer, I'll prefer only ICH because I have these many advantages. But you can see that now you're going for a transformation from IC engine based vehicle to electric vehicles. So surely there'll be some reasons behind that. If you see the government also, if you see in India by 2030, around 30% of the vehicles running on the road will be of electric type. Okay. If you see Japan, right, after 2030, they won't be giving any license for, manufacturing IC engine based vehicle. Even if you see all the manufacturers like Honda, Tesla, everyone, they are just moving into electric vehicles. So such a huge transformation is going to take place. But why? Why we need this one? That's a big question. Okay. Let me list out a few points, but doesn't mean that these are the only points. There are a lot of other things which tells why EV is needed, but let me list out a few points. Okay. The first one we are going to see is the availability of fuel. That means, well, the thing is that existing IC engine-based vehicle, they'll be using fossil fuels, right? Either petrol or diesel or gas. They are not renewable energy sources. Okay, I'll just explain it in the next slide. Well-to-wheel efficiency. If you see the efficiency of an IC engine-based vehicle, it's around 35 to 40. It's only the engine. If you see the efficiency of the engine, IC engine, it's only from 35 to 40%. Okay, but as a whole, if you take all the components, it will still lesser than that. Whereas if you take an electric vehicle, the efficiency is much, much higher. Okay, that is another advantage. And if you see effect of fossil fuels, as we are using only fossil fuels on IC engine-based vehicle, the biggest thing is it's polluting the atmosphere. Okay, so there's a big problem we have. Then we have capital cost and maintenance cost. See, as of now, if we see the initial cost of EV is higher, whereas the maintenance cost is less. Whereas when you go for an IC engine-based vehicle, the initial cost is less, maintenance cost is much more than the EV. But these are the initial stages. Now we have lots of new techniques like battery swapping and all, which makes the cost of the EV totally coming down. That I'll explain once it goes to battery swapping technique. Okay. So these are the few things we have, which tells us why we need to go behind electric vehicle. Let me show you one diagram. This graph which is taken from Google. You can see here, these are the sources and these are the year. Okay, so the first one is coal. Okay, as it is an electric vehicle, I'm not going to coal. Okay, you can just see with oil. Okay, yeah. So right, fossil fuels, that's the petrol and diesel and gas, they are fossil fuels, right? These has been created millions of years before the fossilized remaining of those animals, plants, all these things are converted into coal, and all this history we already studied, right? But the thing is that they are non-renewable energy sources, and they initially we started using them, now we are depleting them in a very faster way. Just think, just if you sit, if you just stand on the road and see for 2 minutes how many vehicles are going here and there. All these vehicles will be using fossil fuels. Just a simple road, you can have such calculations. See the entire town, entire country, the entire world. If you see how many vehicles are running here and there, how much fuel they are consuming. And this is not the only case with the vehicle which are running on the road. If you see the vehicles which is running on water or air, everyone, they are using this only. Right. So just think how much fuel is consumed per day. Okay, and they are not renewable energy sources. Once you dig today, you will get oil. It will get over, you'll go to the next place. Okay, one fine day it will be a circle, and finally nothing is left because they are non renewable energy sources. And as of now, with the scenario we have, if you're depleting in the same rate, probably by 2060 or something, the entire oil wealth will get over. Okay, so that means one fine day after 2060, nothing left for us. Okay, so no petrol, no diesel, no gas. See how many vehicles are running with all these fuels. That means we need to have an alternate fuel. Okay, we need to have an alternate fuel. As all these vehicles are running on fossil fuel, one fine day it will get over and an alternate fuel is needed. Okay, so that is the first thing. Then, even if fuel is available, okay, assuming that I have enough fossil fuel with me, okay, enough petrol, diesel, all such things are there. Even though they are available, there are a lot of other issues with that, okay. So one of the important thing is that pollution. Okay, as we know, right, when you are using vehicles, it will be polluting the atmosphere a lot, right? As you can see, right, when a vehicle is running, how much pollution it is creating. Either it is running in petrol or it is in diesel, it will be polluting the atmosphere. That's the biggest problem we have with vehicles. Okay, and this pollution may lead to a lot of other things also. That means we can have global warming, right? As we use more and more fossil fuels, global warming will be there. The temperature of the earth is increasing. That's mostly because of the burning of fossil fuels. Then the next one is acid rain. As we right, it's not that much common in our country, but still, when you're burning fossil fuels, all these gas will get accumulated in the atmosphere, and when it rains, it will come down as acid rain. That is another issue. And there are a lot of other health hazards with fossil fuels also. A lot of carbon emission, all such things are there. So availability is the first issue. Even though they are available, these many issues are there with the fossil fuel. Okay, so the first one you have seen that we need to find an alternate fuel instead of this fossil fuel. Now we can understand that these alternate fuels should not pollute the atmosphere. Okay, it should not be a cause for global warming, and it should not create acid rain. All such things are there. So now we need to have some alternate technology by which you can implement all such things. Okay. What I'm telling is only with respect to the fuel as of now. Okay. And apart from all such things, apart from these fuels, okay, there are a lot of other advantages with electric vehicles. So that we'll see next. Okay, it doesn't mean that only fuel is advantage, that just using a battery or something instead of petrol or diesel is the only advantage which you can get. That is not the case. There are a lot of other advantages with electric vehicle. First, just to put some general things, okay. Since these motors run quiet than internal combustion engine, as we all know, right, we are using electric motor in our home, right? So they'll run quiet compared to IC engines, right? Even you can see, right, IC engine has a silencer, all such things. If they're not there, you can see how much sound it is creating. So these electric drives or motors, EVs, run quiet compared to IC engines, okay? And these EVs produce no harmful emissions. This we all are sure, right? We have motors in our home, right? We have fan. Everywhere we have motors, right? You can never see they are emitting any gases, right? They'll simply run at most they can create some noise. That's all. Apart from that, there is no harmful emission when you're running an electric motor. So this is what we want. This is what we expect, right? You have seen that when you're running a fossil fuel based vehicle, there are a lot of emissions. Whereas you can see a motor, electric vehicle, there is no emission. So this is what expected from an electric vehicle. Okay, and this I'll tell at the end. So the first is it will run quiet. The next one is there is no emission from the electric vehicles. Okay, next one is the electric drive is very robust, as you know, right? It doesn't need much maintenance. Okay, if you see IC engine-based vehicle, you need lots of maintenance, right? Once in 6 months, I need to take it to the service station. Whereas if it's a diesel vehicle, then at least once in 2 days we need to run for some distance. All the issues are there, right? Whereas when you go for an electric vehicle, this is not the case. You have a motor in your home, right? But very rarely we'll maintain it, right? Once in a year or twice in a year, just clean it and put some grease oil. That's all we'll do. But whereas when you go for a IC engine-based vehicle, it needs periodic maintenance. Okay, so the drive motor, which is used in electric vehicle, okay, needs only less maintenance. And this is one more important thing. Okay, that means we are using motors, right? Approximately the efficiency of the motor is above 95%. But it's only for the motor. When I'm using the drivetrain and all other things, the efficiency will come down, but not below 80. Okay, so the efficiency of it is only for the motor and the IC engine, not the entire drivetrain. Okay. If you see the motor, the efficiency is about 90%, 95%, whereas the same IC engine, if you see the efficiency is only 35 to 40. Just see the huge difference in efficiencies. Okay. It's only for the drive. Okay. So this you can understand, right? It's highly efficient. And the drivetrain is very simple. When you go for EV, second, the drivetrain is very simple. That means the number of components available is very, very less when you go for an electric vehicle. In a simpler way, if you see, it consists of a source, you'll be having a drive, in between that you'll have a power converter. Only three things. I mean, in between that small components may be there. You have a source, you have a power converter, and you have a drive. Whereas if you go for an IC engine based vehicle, you can see n number of components inside. You can see an IC engine, you have filters, you have starter, fuel tank, carburetor, muffler, filter, n number of components are there, right? Lots of components. Okay, so all these things need maintenance. Okay, so the drivetrain is very simple in electric vehicle, where the same drivetrain is much complicated in IC engine based vehicle with lots and lots of components. Okay, so number of components is very less in EV. And this is one more inherent advantage. When you're braking an electric vehicle, it can be used as an alternator for regenerative. This is, I think most of you have already learned what is a regenerative braking, right? So for an electric vehicle, already it is running in a motor, right? A motor will be used for driving it, okay? So when you want to brake it, okay, so it will be converted into a generator, and the kinetic energy available in the wheel will be converted to electrical energy. So the thing is that two things you can achieve. One is you can brake the vehicle. The next you can regenerate the power, and this is inherently available. That you don't want any extra mechanism or extra motor for this one, extra machine, because already it's a motor. It can be converted into a generator. The same machine will work as a motor when it is driving and work as a generator when it is braked. Okay, so this is inherently available inside an electric vehicle. So regenerative braking is there in an electric vehicle, in which we can get the braking as well as we can get energy out of that. Okay, and this is one more advantage which is much needed. Okay, the energy is only supplied when the user needs it. Okay, see, just as in the case of an IC engine, I'm driving. Okay, I'm driving an IC engine based car or anything. If I'm stopping in a signal, okay, normally what they used to tell is that if you're stopping for more than 30 to 40 seconds, just turn off your engine to save fuel. But normally we'll never use it, right? Unless the signal will turn from red to yellow, then to green, then we'll race and go. That's what we generally used to do. So just think that even though the car is idle, the engine is running, right? The car is idle and the engine is running. So that's the case, not only the case with signals. Whenever we are stopping our car, okay, or we are talking to someone, the vehicle will be idle, but the engine will be running. Okay, so this is called a standby losses. That means even though the vehicle is not moving, engine is consuming power if you're not switching off the engine. Whereas when you go for an electric vehicle, the case is totally different. In case of an electric vehicle, you have a power converter inside which will control the power flow. If the vehicle is idle, assume that I have an electric vehicle, I'm stopping in a signal means when the vehicle is idle, no power will be given from the converter to the wheel. Okay, no power will be given from the converter to the wheel. So this is highly efficient. You can save a lot of power. Okay, or when I'm moving in, just stopping the vehicle and just doing some work or talking with someone, if the vehicle is idle, no power will be given to the wheel. Okay, so the power is applied only when the user needs it. So this will save a lot of power when you go for electric vehicle. So lots of advantages are there with electric vehicles. Okay, and you can understand these are the few things which I want to stress, but still there are lots and lots of other things which will tell us why we need to go for electric vehicle. So I'll just show you three diagrams that shows the efficiency of an electric vehicle. So these are all things which is taken from journal papers. They have some proof for the values which they have put. What the values is shown here, they are approximate only. Okay, assuming that, okay, so next one. Assuming that I have an IC engine based vehicle, I'm driving in a city. I have an IC engine based vehicle, I'm driving in a city. Considering that the fuel tank is 100%. Okay, it's not the fuel tank is full. Assuming that 100% input I'm giving to the drive. Okay, and the thing is that the engine losses are approximately 76%. As we have seen, that the efficiency of an engine is only from 35 to 40. Yeah, well, this is 76. So 24% only left from the engine. Standby loss is 8. Standby loss means that you have seen, right? Even though your vehicle is idle, it will be consuming power as the engine is running. Okay. So standby loss is 8%. So only 16% is coming into the drive line. And if you see the drive line, if it has some losses, and you can see only 13% is coming to the wheel. This is the case with an IC engine. If you give 100% input, only 13% is coming to the wheel. Okay, in a city. And if you see the same, if you see the same vehicle when you're driving in a highway, okay, so the engine loss is taken as 77. As we are driving in better speed, more speed than that, the loss is increasing. So it is taken as 77. And standby loss is assumed to be 0 because in a highway it is assumed that there is no signal. You are not stopping the vehicle anywhere. Okay, so it is assumed to be 0. So only 23% is coming to the drive line and it is having some losses. So 90% is coming to the wheel. So whatever case it is, either you are driving in a highway or you are driving in a city, you can see it's always less than 20. If you have seen the efficiency of it is 35 to 40, and if you see the drive line, then it is less than 20 always. So see how much difference is that I'm giving 100% input, I'm getting only less than 19 in the wheel. So that's why these IC engine based vehicles are less efficient. Okay.
One
If you see
second.
this, yeah.
Some participants have unmuted the mic. We request you to mute the mic. Yeah.
Yeah, still it's unmuted, it seems.
Yeah. I'm not finding who is. Kindly mute your mic, everyone. Okay, sir. Sorry. You can carry on.
Okay, ma'am. Yeah, the same when you go for a case with an electric vehicle, okay, we already seen that the efficiency of electric vehicle is above 90%.
All
So
are
it's,
mute only.
the efficiency of electric vehicle is above 90%, so it's 10% losses. And one important thing we need to consider is there is no standby losses because we have seen that power is given to the drive only when it is needed. So here is automatically controlled. So there is no standby losses. So you can see 90% is coming to the drive line. And there is some losses in the drive line. So it's 80%, 86% is coming to the wheel. So you can see both the cases, and I'm having an IC engine based vehicle. If I'm driving in a city or I'm driving in a highway, always you'll get less than 20%, right? Whereas you can see the same electric vehicle when I'm going for a city driving, you can see it's 86%. It's all approximated value, it can be plus or minus. But see the difference. One side it is 20, another side it is F80. So you have 60 difference in between. This is why we are telling that electric drives are highly efficient. Okay, so you can see all these advantages which are seen as a disadvantage for IC engine, they are coming to electric vehicle. It's highly efficient. Okay, there is no emission. All such advantages are there with electric vehicles, right? And if you see the components, what are the important components in electric vehicle? We have normally we used to see only three important components. Okay, one is the drive. It's a motor or generator. That's an electric machine. It can work as a motor or generator. Then we need a source. That input is a source. That can be of any type. Okay, that output should be electrical. That's it. So we have a source. Then we have a drive. Then in between you have a very important component. There is a power converter. Okay, only three main components. One is a drive. That's a machine. Okay, we'll see the type of machines also. Then we have a source as the input. In between that, you have a power converter as the interface. Only three main components are there inside your electric vehicles. We'll see one by one. But I'm not going to deep into all such things. I won't explain the characteristics. I'll just tell you what are the type of motors, what are the type of converters and all. Okay. If you see the classification, you can see a lot of classification for electric vehicles, but I'll just tell you the basic electric vehicle classification. The first one is electric vehicle, we'll generally call it as a BEV. Okay, battery electric vehicle that is running on the batteries. Okay, so that is the first thing, that whenever you tell us electric vehicle, this one which will come to your mind, that is BEV, that is battery electric vehicle. The next one is hybrid electric vehicles, that is a HEV, hybrid electric vehicles. So first one is BEV, that is a battery electric vehicles, and the next one is HEV, that is hybrid electric vehicles. Okay. Then you have the third one is a PHEV, that is a plugged-in hybrid electric vehicle. So there are a lot of classifications in between these. That is a mild, all such things are there. But this is a general one. One is the battery, other one is hybrid, and third is plug-in hybrid electric vehicles. Okay. Let me tell you what is the difference between all these three. Okay. If you see conventional vehicle, this is a conventional electric vehicle where I have fuel. Okay, as a fuel tank I have. Then I have engine. Okay, then I have a transmission. Three are there. Okay, fuel, whatever it is, it's a fossil fuel. Then I have an engine. Okay, right, as a drive. Then I have a transmission. This is a general conventional vehicle. Okay, whereas when the same thing when it goes to battery electric vehicle, that is a BEV. Okay, you have instead of fuel, I have a battery. Okay, instead of engine, I have a motor generator. That's for regenerative braking. We'll use this one. Okay, it can be motor. When it is brake, it can work as a generator, and the transmission is there. Okay, so this is the difference. In case of conventional, you have fuel, engine, transmission. Here it is battery. That's fuel is changed to battery. The engine is for this engine. Instead of engine, you have a motor generator. That is the difference. Now let's go on to the next one. That is what is HEV, hybrid electric vehicle. So the thing is that when you go for electric vehicle, there are a lot of limitations in battery electric vehicle. First one is the capacity of the battery. Okay, with battery electric vehicle, we can go for long distances. Okay? But nowadays, a lot of technologies are there that once you charge, you can go to 500, 600 miles. Like there's a lot of things coming in. When you go for a basic small battery electric vehicle, we can go for long distance driving. Okay, so for such things, right? So this battery electric vehicle in general is mostly suitable for city driving, because whatever advantages you have as regenerative braking, power is given only when the motor needs it. All such things are suitable for city driving. But when you go for highway driving, and it have huge battery capacity. But with the normal BEV, we can go for highway driving. Okay, so the next one is hybrid electric vehicle. Hybrid, as you know, right? It's a combination of minimum two things, right? That means they combine the conventional vehicle and battery electric vehicle to form the hybrid electric vehicle. Okay, so hybrid electric consists of, first one is this side you can see conventional IC engine based vehicle, and this one you have by battery electric vehicles. So it's a combination of battery electric vehicle and IC engine based vehicle. So they are formed this one, hybrid electric vehicles. So we have both battery mode as well as the fuel mode. That means depending upon the requirement, you can use it. When you're driving in city, I can shift to battery mode. And if I'm running in a highway, I can shift to IC engine based mode. So hybrid electric vehicle means it's a combination of both conventional as well as battery electric vehicle. Okay. But the thing is that as far as hybrid electric vehicle is concerned, okay, there is no option to charge from outside. That means this battery will charge only from the wheels and the engine. That's it. It can be charged from the wheels or the engine. There is no option to charge from outside. So, but this battery, I need to, you see, this battery is not the only source which is for lighting, right? This is for driving also. When I'm taking a normal vehicle battery, it is used for lighting, starting and all, but it's nowhere related for driving, right? But when it comes to hybrid electric vehicle, this battery is used for driving also. That means you need to ensure that proper capacity is there in the battery. Okay, but only from the wheel and from the engine, if it is charging, we are not sure that will have that much capacity. So there will be one option given to charge the battery from outside. Okay, if you have some option to charge the battery from outside, then that is called as plugged-in hybrid electric vehicles. When you go for a normal hybrid electric vehicles, there is no option to charge the battery from outside, it will charge internally. Whereas in case of same hybrid electric vehicle, the option is there to charge from outside means it is called as plugged-in hybrid electric vehicle. You can plug it and you can charge it. Either you can plug it into the AC socket and you can charge it, or you can take the supply from the charger and directly give the DC to the this one battery. Anything is possible. That depends upon the type of charging, AC or DC charging. Okay, so this is called as plug-in hybrid electric vehicle. But one problem which will come here is that we have seen all the advantages of electric vehicles, right? But here, if you see hybrid electric vehicle, we are just again putting this into picture. See, as far as battery electric vehicle, it's battery and motor, happy. But come for hybrid electric vehicle, the same IC engine is coming to picture again. Our intention is to reduce the usage of fossil fuel and to eliminate the IC engine because it's less efficient. But when it comes to hybrid electric vehicle, again the same person is coming into picture, right? And the depends on that driving. When you have an option to drive mostly on highway, then obviously we'll prefer only the IC engine mode. Then there is no difference between electric vehicle and this vehicle, right? So there comes the thing which is called as degree of hybridization. Okay, how long you are using, this battery mode and IC engine mode, how efficiently we are using, that will tell you the exact story. Okay, so I'll just put some numbers. Okay, they are just example. Okay, so for example, in the initial stage when hybrid vehicle came into picture, the degree will be 25 and 75. That means 25% of the driving is in battery mode, 75% of the driving is in in IC engine based mode. Then with the improvement in technology, it became, just example, 50-50. That means 50% of the time it is running in battery mode and another 50% of the timing it will run in IC engine based mode. And with the improvement in technology, a lot of improvements in technology came with respect to the battery management system, with respect to the energy density of the battery, with respect to the drives. Lots of technical improvements came, and it can be now 75% and 25%. That means 75% of the timing will run in battery mode only, if it is a highway or if it is a city. Only 25% of the time that we are utilizing the IC. This is what we want. Okay, only 25% of the time we are utilizing the IC engine based mode. And we know, right, a lot of new things are coming up, right? They are going with sodium ion battery, lithium ion battery without anode free lithium ion. A lot of new techniques coming in the battery technology. So one fine day will come where you'll have this 1 second. Please 1 second, let me step back. Yeah. So with the improvement in technology, okay, with the improvement in technology, we can hope that soon it will be 100 and 0. That means one fine day will come where we have highly efficient battery, all such things where the entire IC engine part will be eliminated. Surely that is not that much far. We hope that. Okay. So these are the various classifications of electric vehicles. Okay. Now let me just show in a glance what are the types of vehicles we have. See, if you see Nissan Leaf, okay, this is Nissan Leaf. This is simply a battery electric vehicle, right? There is a no IC engine inside. It's just a battery electric vehicle. This is called as actually generally we used to call this Nissan Leaf as iPhone in wheels, because each and everything inside that you can control it. Okay, and I think they are claiming that nearly 75% of the part of this vehicle is green. It's also called as a green vehicle, right? Because it's claimed that around 75 to 80% of the parts in an electric vehicle, it is recycled parts. Okay, the other parts we have the old vehicle, they are recycled and they are using it for this one. So, and it's each and everything is controlled. That's why it's simple name, pet name is there. It's an iPhone on wheels. Okay. So this is actually battery electric vehicle. Nissan Leaf is a battery electric vehicle. So there is no IC engine inside. Whereas when you go for this theory, you go for this also I told degree of hybridization. Nowadays you can see that the traction power provided by the IC engine is reduced and electric motor is increased. That means that most of the times you'll go with electric mode, where less time you'll go for IC engine based mode, and soon this IC engine will be totally eliminated. That is the expectation we have. Okay. And this is a PHEV, Chevrolet Volt. If you see Chevrolet Volt, not only Volt, Chevrolet Bolt, all these things are plug-in hybrid electric vehicles. Because having a hybrid electric vehicle is a pleasure advantage, but we don't have an option to charge from outside. But such things now, plug-in hybrid, we can charge from outside. That's more advantageous, right? So mostly nowadays people are preferring PHEVs only. Okay, you can see here these are a few examples. If you see Nissan Leaf, is a pure electric car, battery electric vehicle. If you see Toyota Prius, it's a hybrid. Okay, whereas if you go for a Volkswagen Golf, okay, then a lot of other things, right? Chevrolet Bolt, Tesla 5, Tesla models, all they are now it's with plug-in hybrid electric vehicles. Okay, so these are the few vehicles which are there on the road now. Okay. And if you see the types of, see, I'm not going deeply into motor, I'll just explain the parts. Okay, then I'll tell you where green is coming. If we see the types of motor, we have studied lots and lots of motors in our subjects, right? We can go for either the brushless DC motor. Okay, it doesn't mean that this is the only motor which is used in a machine. Okay, sorry, in an electric vehicle. There are a lot of types of motors used. It depends upon the manufacturer. Okay, they can go for a brushless DC motor. They may go for a PMS, a permanent magnet synchronous motor. Then they can go for induction motors also. That depends. Okay, so you can go for brushless DC motor, PLDC, PMSM is there, induction motor is there, and permanent magnet SRM is also there. So these are the few types of motors which are used in electric vehicles. Okay, it depends upon the manufacturers. For example, if I'm seeing small vehicles, like the power rating is very less, like three-wheelers, two-wheelers, electric rickshaws and all, they are mostly going with brushless DC motor. Who are the manufacturers? Small low power vehicles like two-wheelers are there, right? Then three-wheelers are there, e-rickshaws are there. All these things they'll be mostly going for brushless DC motor. So low power electric vehicles like two-wheelers and three-wheelers, irrespective of the manufacturer, they'll be using brushless electric DC motor. Then depends on the, for high powered vehicles, each manufacturer they are going with different types of motor. If you see PMSM, Volkswagen, Nissan, Chevrolet, Hyundai, everyone they are going with permanent magnet synchronous motor. Okay, but obviously induction motor is Tesla. Okay, they are using induction motor. But now they made a change when you go for Tesla Model 3, they are using permanent magnet switch reluctance motor. So does it mean that only a simple motor is used for a vehicle? It depends upon the manufacturer. They have their own R&D team, because this PMS, permanent magnet switch reluctance motor, if you go deep into this Tesla Model 3, they are telling that it's a 6-phase motor. So they have their own R&D station where all these things are developed and they are using it of own. So it doesn't mean that only induction is used, or it doesn't mean that only PMSM is used. Depends upon the manufacturer, they are having their own motors. Okay, so these are the types of motors. And if you see the source, okay, so lithium-ion batteries are there. So that is mostly used nowadays, right? Whereas in old vehicle we have lead-acid batteries. That is a single battery we have. Whereas nowadays, if you see, most all these things are running in lithium-ion batteries. Okay. Then we have nickel metal hydride. Those things are not used nowadays. Okay, lead acid is used for a normal vehicle which we have, they'll go for lead acid battery. Whereas it doesn't mean it's only for electric vehicles. See, nowadays, whatever applications we have, we'll go with lithium ion, right? If you see the charger in a laptop, if you see the mobile, I mean, sorry, not charger, if you see the battery in the laptop, or if you see a mobile battery, all such things are lithium ion only. And nowadays, all electric vehicles are running with lithium ion batteries because it's a high energy density is there, right? That is the biggest advantage of lithium ion batteries, right? And it's not a single one, right? It's a lot of cells are arranged in series parallel depending upon the requirement to get the rating. Okay, so mostly lithium ion is preferred. But the thing is that as of now, it is understood that the batteries all are lithium ion type, but this is not the case after 5 years. Okay, because the problem with lithium ion is having a lot of advantages like high energy density, all such things. Okay, and if you see the cost of lithium ion batteries, initially it was very high, now it's slowly coming down. All such things are advantages, but there are few disadvantages also. One thing is that lithium ore is not renewable. Okay, lithium ore is not renewable, and we are using a lot of other things like cobalt, all such things inside, which is hazardous. Okay, so since it is not renewable, on the other side, if you see after 5 to 6 years, we can expect that most of the cars which are running on the roads will be electric vehicles. So there will be a huge demand for batteries at that time. But see the lithium ion, it is non-renewable source, right? We can't expect that lithium ion will serve for all those things, right? Scarcity will be there, shortage will come, price will increase. Okay, and a lot of issues are there with lithium, like something called as dendrites. Okay, it will form a layer between anode and cathode or something, so that will reduce the life of the battery. So a few issues are there with lithium ion. So it doesn't mean that lithium ion is there always. After 5 years, surely the scenario will change. Because nowadays you can see that each and every manufacturers, they are having a lot of things in their research. They are using sodium, some like Honda or something. They are going for sodium ion batteries. They have research on sodium ion batteries. Okay, then lithium sulfur batteries, there is a research on lithium sulfur batteries. So each manufacturers like Hyundai, Honda, they are having their own R&D for different type of batteries. Someone is developing lithium ion, someone is developing sodium ion, someone is going for lithium sulfur batteries. And if you see Tesla, I think Tesla, they are going for anode free batteries like this lithium ion same battery. You studied anode and cathode will be there, but they came up with a pattern where there is no anode in the battery. Okay, and high energy density. So it doesn't mean that this lithium ion will be ruling the world after 5 years. And you see after 5 years, I think different type of batteries will come. Okay, but as of now, we have only lithium ion. All the remaining batteries are still in research level. Yeah. But if you see lithium ion, obviously all manufacturers, okay, all vehicle manufacturers as of now, they are going into others. Still the research is there with other batteries, but commercially they haven't put in electrics. They are just, some are patented and some are in research stage. But soon we expect, because energy density is the one which we need, right? Because once you are charging, if it's running for only 100 kilometers, if you're driving in a highway, then it's very tough. I need to find some charging stations, right? Whereas if you have a battery with a high energy density, that is one, I'm hoping that is from lithium sulfur, I'm not sure. There's one thing came up that once you are charging, if you charge a battery once, it will run up to 3,000 miles. But it's not commercially done, it's just a research stage, they are told. So if such things are coming up, just think of a condition. Once I charge, I can run up to 3,000 miles. Okay, so hope that all these things will come up. Okay, and you can see these are the battery packs we have. If you see it's really old, you can see this huge battery pack you have there. Yeah, and the next one, the last one in this one is AC charging. Okay, this is another important thing, right? Because charging, whatever it is, there are all such advantages we have seen. But how to charge the vehicle? How to charge the battery? That is the next thing. There are a lot of classifications. In somewhere you can see that you can have a level 1 charging, you can have a level 2, level 3. Some classifications will go like this. In some books, some papers you can see that is AC charging, DC charging. All such things are there. I just classified according to the charging. But whatever case it is, finally it is DC because batteries charge DC only. But depending upon the sorry, it can be classified as AC and DC charging. Okay. If I'm going for AC charging, it's an onboard charging. That means the charger, I'll just show you the picture also. The charger is inside your vehicle itself. Okay. So onboard means the way charger is in the board itself. Inside your vehicle itself, you'll be having the charger. Okay. Just you'll be having a wire and plug. Just plug it and you can charge it. That's the thing. Okay. And in case of onboard charging, we have two levels. There is level 1 and level 2. But the power capacity is different. Okay, level 1 is for low capacity, and you can see that it takes around 8 hours of charging. That is overnight charging mostly. Just after night, just put it in charging, and the morning you can take it. This is actually level 1 charging. Just put it in the socket and you can charge it. Whereas if you go for level 2, it's for just power level is a bit more than that. And you can have around 3 to 8 hours charging. Okay. But whatever case it is, you can see AC charging, it's either 3 to 4 hours or 8. That means minimum 3 to 4 hours it takes for charge, right? But this is not what we expect, right? Because we are telling that this IC engine, I mean, EV is a counterpart of IC engine. You can just see the difference. 4 hours of charging is needed, but only 10 minutes is needed for filling the petrol or diesel, right? So this charging time is an important issue, but we have a few solutions also. Two type of solution is there. One is that we have a lot of technologies there where the charging is made very fast. Another side, we have some new technologies called as battery swapping also. So whatever problems we see with electric vehicle, we have technologies for that, okay, to eliminate it. That's a huge area of research. If I'm seeing, this is actually a Tesla model. Okay, you can see onboard charging. It's behind the seat, it seems. The charger is inside your vehicle itself. Okay, so charger will be available inside your vehicle. This is actually Chevrolet. You can see the charger. Okay, the charger is inside your vehicle itself. That means just plug it and you can charge it. Okay, but the thing is that as the charger is inside your vehicle, mostly the capacity will be restricted, because when you're going to go for high power charging, okay, then the thing is that the component size will be more, right? When you want to increase the power rating, as we know, power electronics, right? As the power rating increases, the component size will increase. Okay, heat generated will increase. All such things, size will be huge. So all such things are there, right? So when you go for onboard charging, mostly it will be low power because charger is inside your vehicle. Okay, but the thing is that 3 hours, 4 hours is very tough, right? So we have the next one as DC charging or level 3 charging. This is actually a fast charging. Okay, and this is off-board charging. The power rating of this charging, this is very high. Okay, and that's why these are the charging stations. Okay, whereas onboard charging is inside a vehicle, whereas DC charging mostly with the charging station. Okay, so the power capacity is very high. But the thing is that this is off board because it is in the charging station. Okay, and the thing is that uh, you have a lot of things inside because the power rating is very high. So the device size will be there, it will be huge. A lot of power losses are there. Then heat management is needed. All such things are there, right? So it's heavy and costly. So more, it will be actually off-board charging only. We can't keep such a big charger inside your vehicle. Okay. So DC charging or level 3 charging is mostly off-board charging, and that will be with a charging station. Okay. And it is told that 80% of the charge will be reached in 30 minutes. See the difference. There it is 3 hours, 8 hours, all such things. Here 30% of the charge will be there in 80% of the charge will be there within 30 minutes time. Okay. But one advantage with this is that charging time is very less. Another one is that anyone can use this one, right? When you go for an onboard charging, only your car can use it, right? Directly you can plug. But we have another new technologies like vehicle to grid, vehicle to vehicle. All these things are there now. Okay. When you go for off-board charging, the advantage is that anyone can use it. Okay. But there are a few disadvantages. So one is higher losses because power capacity is high. So losses is high, size, cost, all such things are bigger. Okay, and one more thing is that 80% of charge can be done only with the fast. Only fast charging normally will go for 80% of charging, because when you go deeply into the charging cycle of a battery, we can see that normally we go for constant current and constant voltage charging. So fast charging means normally it will be with constant current charging. So beyond certain level, we can go for constant current, because when it is reaching a certain voltage level, we need to go for constant voltage charging only. So beyond 80%, we can use this one. Okay, and one more important thing with respect to this charging is that, so the life, if you see the life of the battery, there are a lot of factors which will determine the life of the battery. One is the number of charging, number of discharging cycles, okay, number of time you are charging and discharging. Another thing is that the way in which you are using the battery. Okay, see, if you take an IC engine based vehicle, if you see that some drivers they'll drive normally, whereas there are few drivers they'll go for rash driving, suddenly increasing the acceleration, then change. All such things are there, right? Again, if you use a battery as a source, certainly if you are increasing the acceleration, means more power will draw from the battery. So the way in which you are using the vehicle also will decide the life of the battery. Okay, so number of charging discharging cycle. Another one is the way in which you are using. Another important thing about the life of the battery is the C rate. C rate means charging rate. The rate in which you are charging. For each and every battery, they will specify what is the charging rate. Whereas when you go for fast charging, it will be more than the specific charging rate of the battery. So it is a trade-off. One side you have an advantage that you can charge very faster, but another side you have a problem that the life of the battery will come down. Okay, so that is the thing. Okay, so advantages are there, and you have a few disadvantages also. Okay, with this level 3 charge. Once again. And this smart charging, I'm taking it now. At the end, if time permits, I'll take smart charging. Okay. Now let's come to another very interesting topic in EV, that is battery swap. Okay. If time permits, I'll take smart charging. Okay. So first thing is that whenever you take electric vehicles into picture, the first thing comes in your mind is the charging time. We have seen these chargings, right? 1 hour, 4 hour, 8 hours, all such things. But this is okay for the normal condition. Whereas if it's an emergency condition, for example, we have a taxi. Okay, some cab is there. Someone is going for an urgent trip. Suddenly, the battery is down. If he's going to a charging station, you are in a queue. Okay, let it be. But even though if you got the chance that if they tell them to wait for 1 hour for charging a battery, means it's not fair, right? It won't be good. For commercial vehicles and all, maybe if it's a personal vehicle means I can wait for some time. Whereas commercial vehicle, if they're willing to wait for 1 hour means it's not good, right? It won't be working. Or else if you see an emergency condition where an ambulance is coming, okay, whose battery is down, maybe we will give way for that such that it can go to charging directly. But if it is going to the charging station, for all the vehicles it will be the same, right? If it's an ambulance also it will take big time for charging. So that is the biggest problem we have, charging time. Whereas these fuels you can fill within 5 to 10 minutes, but charging is in hours. Okay, so that's the biggest problem we face. So that is why we are thinking if this problem is there, how to go for electric vehicles. Another one is a range anxiety. That means if you charge once, you go for 100 kilometers. Then for the next 100 kilometers, after 100 kilometers, I need to find some charging station. So where I can charge it, I can charge my vehicle. I need to go in search of that. So thing is, the two things will be there in the mind. One is the charging time. Other one is the range anxiety. Okay. So battery swapping is a new technology. It's a technology which will eliminate all the issues of this charging. Okay. But on other side, when you go for battery charging, a lot of new technologies came like smart charging and all, where you can use a lot of renewable energy sources, and we can, on the other side, we can use a lot of new technologies which will charge your battery very faster. So that is one side. Another side, we have a technology which is called as battery swapping. Okay, this is implemented in India also. Okay, the thing is that it's simple as of now. I think Sun Mobility is doing this in India. Okay. Just the thing is that swap the battery. That's all. Swap the battery. Come with a low battery. Give the battery for the charging. Take another battery and go. That's it. Just swap it. Okay. I am as in that I have a vehicle. I'm just entering the charging station with a low battery. I'll give the low battery and I'll take the battery which is charged already and kept it there and come out. Just think how much time it will take. It's just an example they are told. If I'm using an Ashok Leyland bus, okay, it took only 30 minutes. It's actually automatic change. Okay, machines are there to change it. It took only 2.5 minutes for a big bus to change the batteries. The same bus, if it is going to fill fuel, you can understand that it will take minimum 10 minutes, right? It's a huge vehicle, right? It will take minimum 10 minutes. But with battery swapping technology, you can think that just within 2.5 minutes, the battery is swapped. Okay, so just to see the range density or the charging time, all such things will go up when you have such a technology. Okay, swapping the batteries, and depending upon the charge which we have in your battery, you will be you need to pay. Okay, but it's an account with something inside. Okay, it will be debited. That things are there already. So just give the battery, see how much charge is left in the battery, and you need to pay according to that only. Okay, so this is highly advantageous. And the thing is that if it's through renewable energy sources, then it's much advantage. I'll tell after this. Okay. And as of now, it is you're having a tie-up with Piaggi Autos. I think in Bangalore it's there. Okay. So all the Piaggi Autos which are running, okay, they have a tie-up with the Sun Mobility. And for these autos, they can directly go to the service station. They can directly go to the swapping station, just swap the batteries and come up. That's it. Okay. So it's very easy. And the thing is that, but this is how, okay. just replace the battery. It's not only for autos, just in two-wheelers, they have a rack with charged batteries. They'll be having another rack for charging the batteries. Just go there, replace the battery and come out. This is actually battery swapping. Okay. And in India, actually, IOC, Indian Oil, they are going to launch around 62,000, I see, I'm sure. I'm not sure, around 62,000 something is there. Okay, that means IOC, Indian Oil Corporation, wherever they have petrol bunks, they are going to implement this battery swapping there itself. Okay, so one side will have petrol filling, diesel filling and all, and another side will be having a battery swapping. Okay, so you are just go there, replace it and come. Okay, just see the option. Okay, because they are not going to have new charging stations. What they have planned is the existing petrol bunk itself, they have one part for EV now. Okay, there will be having a battery swapping. Just go there, swap it and come. Okay. So this is advantage. Okay. Again, the same Sun Mobility is coming into picture for battery swapping with Indian Oil Corporation. Okay. So you can understand that the problem with the charging will be avoided with such case. You don't want to wait for much hours, maximum 2 to 3 minutes. That's all. Just change the battery and come out. Okay. But you may feel there are some issue with that. I'll tell you what are the things. Okay. Then one more important thing, we can feel that this is the only advantage, right? That means swapping the battery, time saving. That's the thing. But there is another big advantage with battery swapping. There is that if you see the cost of electric vehicles, okay, if I'm seeing the cost of electric vehicle, as in that initial itself we are seeing the cost of vehicle is very high, right? But if you see the cost of electric vehicle, about 40 to 50% of the cost is for the battery only. About 40 to 50% of the cost of an electric vehicle is for the battery. Okay, but now what they are coming up with the new technique is that your electric vehicle will come without a battery. The electric vehicle will come without a battery. Only these swapping stations, they will own a battery. Just take your car, go to swapping station, first put your battery, then replace it according to your driving. That means initially the car will come without battery. Okay, then once it is done, you can go to a station, you can put a battery and you can start running with it. So what the thing is that since the car is not coming with the battery, the initial cost of the car will be reduced by around 50%. So this is what we are seeing. The initial cost of electric vehicle is higher than IC engine based vehicle. But when you go for such techniques, you can understand that the initial cost of car will come down by 50%. Okay, so that is another biggest advantage. Only thing is that you need to pay some initial cost for the battery, then just charge, discharge. That is according to the usage. That's it. Okay. You can see that it's around 40 to 60% of the cost for EV is from the battery itself, for the battery itself. But the thing is that, so end user has to pay only for the charging and discharging or some initial cost, all such things. So the cost of the vehicle will come down still. Okay. So what are the problems we are seeing with charging time, the cost of the battery, cost of the vehicle, all such things are now eliminated with the new technologies we have. Okay. But thing is that we need an equivalent infrastructure to that. And see the way in which the battery is used, all such things are affected. Okay. Because someone can use it very roughly, someone can use it very smoothly. So the battery life is not that much maintained. That depends upon the usage. And one more important thing is that grid load management. One more important thing is that as of now, it's lithium-ion battery. Okay. But after 5 years, if n number of batteries are coming up, then this will be a big problem, because if someone Volkswagen comes, their battery is different. If Tesla comes, their battery is different. So that time we'll be having some issues, it seems, but surely this will be sorted out. Okay, so this is another promising technology when you go for electric vehicles, that is battery swapping. Okay, well, and this just yeah. Now the next thing. Okay. Okay, we have seen all the advantages of electric vehicles, right? We have seen the components also. Okay, but main thing we need is that we need to make things clean, right? There should not be any pollution. Okay, it's full of green, right? That's what we expect. But the thing is that, so let me see the first one. You can see that I have a vehicle. You can see this much pollution is there. Okay, so this is the first issue we have. We need to eliminate it, right? Now the thing is that it's an electric vehicle now. It's pretty good, but there is no emission in the electric vehicle. So from the vehicle point of view, it's green. It's clean, right? There is no pollution because I'm using a motor. There is no emission from the vehicle. But just think of a condition. If you're charging your battery from the grid, okay? If you're charging the battery from the grid, Okay, so the same amount of power has to be generated in the grid, right? So instead of increasing the pollution in the instead of increasing the having pollution in car, you will be polluting the atmosphere from the grid itself. Initially, there was no grid in the picture in this case, right? So think of a condition where the country is having mostly dependent on fossil fuel. For example, India, right, around 69% of the power generation is from fossil fuel only. Okay, so think of a country like India. In the first thing, I have pollution only from the vehicle. There is nothing even with respect to the grid here. But in the second one, I have eliminated all these IC engine based vehicle. I have battery pack. I'm running clean vehicle is there. But if the same battery is charged from a grid, then the amount of power has to be generated from the grid, right? And it doesn't mean that the same amount is generated, because right, when you're generating power, it will go as transmission and distribution losses, and only the remaining power will come to the end user, right? So more amount of power has to be generated at the grid side. Okay, so instead of having a pollution in a vehicle, you are polluting the atmosphere from the grid side, right? So both are more or less the same here, right? So if this is the thing which you are going to use, then only the advantage with vehicle will get, right? Vehicle means regenerative braking, power saving when the vehicle is not running. Only these much advantage you will get from the vehicle. Remaining with respect to the fuel, all those things you will never get, because same amount of more amount of emission is there from the grid now. Okay, so this is not a clean thing. Okay, it's like a lot of terminals there, right? For example, if you have an electric vehicle, it's equivalent of carrying a thermal power station with you, right? Because charging we need. Okay, so now the thing is that we need to move into renewable energy sources for the charging of vehicles. So whatever charging stations you are going to build, whatever new charging stations are going to come, it should be mostly charged from renewable energy sources. Only then we can go get all the advantages of electric vehicles. If you're charging the vehicles only from the grid, means there is no use of that, right? Again, you'll be polluting there, you'll be using fossil fuels, all such things. So only when you're having more and more renewable energy sources for charging the vehicle, then only you can get most of the advantages of the electric vehicle, right? What are the charging stations you are going to build? It should be mostly with respect to electric. That means, right, when you go for smart grid and all, that's a big terminology we have, where which will be mostly going for distributed generation. There will be using lots of renewable energy sources. So only when such things are coming into picture, when you go for charging stations with renewable energy sources, lots and lots of renewable energy sources, then only we can get all the advantages from electric vehicles. If it is only with respect to the drive, and if you're charging the grid, means there is no use, still fossil fuel will be used there. Okay, and there are a few other things also, right? In some conditions, they are using charging in the vehicle itself. You can see, right? A car is there with solar panels in the top. Even this is another one. It's from China. You can see buses have solar panels in the top. So while running itself, they'll charge. But it doesn't mean that I think the entire battery will be charged by this one. But a part of the charging you can get it from this one also. So everywhere now they are going to have renewable energy sources for charging. Okay, so that we can go fully green vehicle now. Okay. Right. So what else you have seen till now is with respect to the grid to vehicle. That means the power is taken from grid to. It is understood that when you go for charging or whatever it is, it's understood that the power is taken from the grid to vehicle. Okay. So this what I have seen is the basics of grid to vehicle technology. But this is not a small topic. How for each and everyone you have lots and lots of things needed, right? It's just I told one slide on battery, but it's a huge topic. Motors is a huge topic, but just an introduction again. So these are the grid to vehicle technology. But now let's move on to the next one, that is the vehicle to grid technology. But before going into vehicle to grid technology, let's see a small introduction to demand side management, that is DSM. Okay, and this is also pronounced nowadays, right? Demand side management. So we need for DSM, there are a lot of reasons why we need to go for demand side management. One is that as we know, right, if you're saying 1 unit of electricity, which will avoid 2 times of capacity addition. These are the general things we can have. That means it doesn't mean that if I'm using 1 unit of power here, it doesn't mean that 1 unit is generated there, right? After generation, you'll be having transmission, you'll have distribution, a lot of transmission losses. When it comes to distribution, the main factor is there, right? AT&C losses, aggregate technical and commercial losses are there. So when you see all such things, if you're saying 1 unit, it's equivalent to adding 2.5 times there. Okay, equivalent to reducing 2.5 times the generation there. Okay. And another one is that if you want to see as the demand of power is increasing, we could increase the generation according to that, right? I think someone has unmuted, some disturbance is there. So thing is that as if you want to add 1 megawatt capacity of thermal power, it requires 6 crores for installation and 3 crores for transmission. That means with the existing power itself, we need to meet the demand. Okay, that is the basics of DSM. DSM tells that with the existing generation and for the existing demand, how you can match it. That's what DSM tells. Ma'am, there is someone unmuted, ma'am. It's disturbing.
Yeah, request. The participants to unmute, mute your mic, please.
Okay, ma'am, let me continue.
Yeah, 1 second, sir. Okay, sir, you can carry on. Sriji, sir?
Oh, yeah, 1 second.
Yeah.
Okay. Just this simple load curve. With this one, I'll explain what is DSM and why I need to go for DSM. Okay. So as we know, right, the demand for the daily, right, it's changing with respect to time. Whatever demand we have at 8 o'clock, that is difference with 9. I mean, there is difference between 8 o'clock and 9 o'clock demand. At 12 o'clock, it will be different. Evening, it will be different. Each time the demand is different, right? So this is a load curve. We can see from the morning midnight 12 to the next day you are having graph in a different manner, right? Sometimes it is less, sometimes it is constant, sometimes it is going to peak. So we'll tell them something as an off, I mean peak load time and somewhere is an off peak time, right? So if, for example, if you see this graph, you can understand that for around demand is minimum from 12 to 6. So early morning the demand is something around 2700. Okay, in the noon time till evening the demand is approximately 3000, and at night time you can see from 5:30 to 9:30 things are approximately 4200, just approximately. You can see the demand is changing with respect to all these timings, right? So what type of capacity we can use it for such things, because it's a practical one, right? If you're having a capacity of 2700, it can serve only for a certain period of time. When the demand is increasing, I can't serve it, right? So another one is that I'm having a capacity of 4200. I'm adding huge demand, that capacity I'm putting. If this can serve the peak load time, whereas during the off peak time, all these things will be ideal, right? So having a very less generation, we can serve all the loads. Having a huge generation we have, it will serve the load. But the thing is that for some time, most of the times, few of the generations will be idle. Okay, so we need to have a trade-off between this one. Okay, and one more thing is that if you see the cost of power generation during peak demand period, the cost of power generation is much higher, because we'll be putting all the generators in the picture during peak demand period, so which will increase the cost of power generation. And another thing is that as the more number of generators are put into picture, the emission will still increase. And if the utility is not able to supply the demand, okay, they need to take power from outside at higher cost. So the peak demand period, the problem is that demand is huge, cost of generation is huge, emission is higher, and if they are buying from outside, still cost will increase. Okay, so some solution has to be there for such kind of things. Okay, so one of the best solution we had is demand side management, managing this demand, okay, from the customer side. You can see that the peak demand is around 4300. It's only for short duration of time, okay, whereas all other demands we have mostly, and you can see the difference. So most of the time it will be approximately 3000, whereas only for short duration of time we have 4300 demand, only for short duration of time. We need only that for just for a small duration. Okay, either they need to have a huge capacity to do all these things, or they need to buy power from outside to serve the demand. Whatever it is, the utility is going to suffer. Okay, so there should be some option to eliminate all these things. And when you go for a demand side management, okay, the benefit is for both customer as well as the utility. That is the important thing. See, that is the thing where the customer can participate in that. Okay, the advantages, benefit is there for both customer as well as the utility. Okay, the thing is that, so what the utility will try to do? okay, with respect to Unico for demand side management. The thing is that it will encourage us to use less energy during peak hours. Okay, it will encourage the user to use less energy during peak hours, and they'll encourage us to use more energy during off peak hours. That is the thing which this is the basics of demand side management. We have a lot of other techniques there, a lot of other things are there. But still, the basic thing is that use more energy during off peak hours and use less energy during peak hours. This is the thing. This is the basics of TSM. Let me tell you what is actually what benefit you are going to get from this one. Okay. Okay. Let's see that. Okay. See, there is something called as a time of the day pricing or time TOD or a time of the use TOU pricing. The thing is that we don't have that in India as of now for the domestic customers. The thing is that the cost of power generation is not fixed with respect to time. Okay, for each time the cost of power generation is increasing. Okay, I mean it is changing, it's not increasing, it will change. That means during off peak hours the cost of power generation will be less, and during peak hours the cost of power generation is more. So the thing is that what are we are paying, it's a fixed, right? Only the slab will change. 0 to 100 units, some state it's free. 100 to 200 units, I'll pay 10 to 5 rupees per unit. Then 200 to 300, it is 10 rupees per unit for something like that. So it's only with respect to the way in which you are consuming. It's not with the time. It's with respect to the amount of energy you are consuming, you need to pay. Okay. But if you see practically, the cost of power generation is different. At off peak hours, it is less, and peak hours, it is more. So thing is that, but we are paying only a fixed, okay. So we are not, the customers are not getting the advantage of this change in price, but it is there in other countries also. Okay, so what generally is people used to do is that, see, in other countries they have smart metering systems and all, and they can see the tariff, this tariff, that tariff, like this you can see the tariff also. Okay, so what the customers are encouraged means they need to use more power during off peak hours. So the advantage of using more power during off peak hours is that during off peak hours the tariff is very less. Okay, since I am using more power during off peak hours, as the customer I need to pay only less, because for example in a home I have certain loads, right? Most of the loads if I'm using in off peak hours the customer has to pay only less. So that is a benefit for the customer. Okay. The next one, during peak hours the utility will encourage the users to use less power. Okay, so if it is less power is used, the advantage for the customer is that during peak load time the tariff is very high. So when tariff is very high, as the customer is using only less load, again he need to pay less. So off peak hours he has used more load, but the tariff is very less, so he has to pay only less. Customer has to pay only less. Peak hours tariff is very high, but the customer has reduced his usage. He has used only very less loads. So in this case also customer has to pay only less. So both the cases you can see customer is benefiting. Okay, that is a benefit for the customer. What is the benefit for the utility? The first benefit is with respect to the peak time. In the peak demand time, since the customers are using only less power, okay, customers are using only less power, what will happen is that the demand is very less, right? That means they don't want to generate that much higher, okay? So they don't want to put the costly generators into picture. So as all these things are done, the cost of power generation will be less. And since only less generators are running, costly generators are not running, only less generators are running, the emission will be reduced, and the utility don't want to buy power from outside. So the benefit for utility you can see less power generation, less cost, less emission. Okay, and you can see the curve, right? It is going peak during the peak demand period, whereas it's coming down during the off peak period. But when customers start using more power during off peak and less power during peak, your curve will be flat normally. But doesn't mean that all the loads can be shifted to off peak hours. There is restriction is there, because for example, if I'm taking air conditioner, I need to use only when it is needed. I can't wait the time at which the tariff is less. Instead of using air conditioner at the hot and humid climate, we can't wait for the tariff to be reduced and use in the midnight, right? So certain things we can't change the timings, but there are a lot of other applications, appliances where you can change the timing of usage and you can make benefit out of this one. This is the basics of this one, demand side management. Okay, clear? I'll just show you. Yeah. These are strategies. This is how it is done. Okay, so there are a lot of strategies for demand side management. You can see this is our college is load shifting. You can see just this black, this is a old curve. You can see it is coming like this. Okay, yeah. And the second one is a new curve. We can see that as far as the utility is concerned, they'll encourage the users to use more power during off-peak hours. You can see the load is increased here. And they'll encourage the users to use less power during peak hours. You can see the load came here. So now you can see the load curve is a bit flat. There is a benefit for the utility and there is benefit for the customers. Everyone will be benefited. Okay. So this is the basic thing for the demand side management. Okay. And this is a simple one. The main goal of DSM is to encourage the customers using less energy during peak hours and more energy during off-peak hours, such that everyone will be benefited. But the thing is that if you want to implement this one, we need to have the time of the day price, TOD, time of the day or time of the use, because the customer has to know when the tariff is very less. According to that only we can use, right? But as of now, what the thing we can't do that, because we have an energy meter, it can be digital meter, but we don't have the tariff. Okay, right? We don't have the tariff for each and every time, right? Only the fixed tariff we have. It will change with respect to slab. Only when this time of the day tariff is given, then only we can go for such kind of things. In India, for domestic customers, we don't have a time of the tariff till now, but for HV installations they have. But in other countries, they have TODs. Okay, if that is there, then you can easily go for vehicle to grid technology. Okay, I'll just tell you here. You can time of the tariff is used for industrial sector now. Slowly it is introducing as commercial. Maybe after some time it will come for commercial sector also. So TOD means time of the day. Each time the tariff will be changed. Okay. So this is demand side management, right? Now let's see how okay, this is utilized for a vehicle, electric vehicle. See, the thing is that if it is an electric vehicle, okay, from outside if you see, it is just a vehicle, right? Just to drive. But this is actually a different person who can help you a lot in the grid also. Okay, this is the one which can help you a lot in the grid also. When you go for smart grid, you can understand. Vehicle is not the one which is used just to travel. Okay, it is helping to maintain the grid load always. Whenever the load is less, it can take power and it can charge. Whenever the load is demand is more, it can help the grid by giving power. Okay, so when it comes to plugged in electric, when you come to electric vehicles, it's not only used for driving. It is serving a lot of other things. Okay, so don't look PHEV as just a load which is used for driving. This is a lot of other advantages. Let me tell you what is a vehicle to grid technology. Okay, V2G. See, if I take a single vehicle, okay, if I'm taking an electric vehicle, okay, you can see that it has a huge capacity inside, right? You have seen how much, see, this much huge vehicle means obviously the battery capacity will be very huge, right, to drive the vehicle, right? So that much huge capacity is there inside a vehicle, okay? And one more thing is that at any point of time, okay, we can't tell that 100% of the vehicles will be running, okay? But if you see the journal papers, they have predicted that at any point of time, 60% of the vehicles will be idle. See, I have 2 or 3 vehicles also. At any point of time, I can use only one vehicle, right? And most of the times, if you see the parking lots or some malls and all, you can see a lot of vehicles parked there. So if you see the scenario, at any point of time, around 60% of the vehicles in the roads will be idle. Okay, 1 second. Vehicles will be idle, and if they are normal vehicles, but they are electric vehicles, okay, so they have huge power saved inside. Okay, so that is the first thing, right? So most of the vehicles are idle, around 60% of the vehicles are idle, so they have huge capacity stored inside. The next time is when you go for the grid during peak demand time, peak demand period, grid needs a lot of support, because during peak demand time the demand is increasing, they need to increase the generation, cost, emission, everything will increase, and they need to get power from outside. So if someone is there to help the grid during this period, if someone is there to give power to the grid during that period, it is much beneficial to the grid, right? That is what we need to do. So there only your vehicle is going to help. Okay, that means during peak demand period, okay, whenever the grid is needing the support, your grid will supply, or sorry, your vehicle will supply power to the grid. Okay, so 1 second. So whenever the grid is needing power, the huge capacity which is stored inside the vehicle is given back to the grid. So the power in a vehicle is given back to the grid, and this is called as vehicle to grid technology. The first one we have seen is that power from the grid is used for charging your battery. That is, the power is flowing from the grid to vehicle, that is G to V. Now the power which is stored in a vehicle is given back to the grid, that is V to G. But there are a lot of other techniques also, V2B, vehicle to building, V2V, vehicle to vehicle, a lot of other technologies too, but I'm not going to do deep in that. So vehicle to grid technology means the power which is available in a vehicle is given to the grid. Okay, that is called as vehicle to grid technology. But if you see one vehicle, there is of no use, right? But if you have n number of electric vehicles giving power to the grid, means it will be a huge benefit. Lot of power will be going to the grid. Okay, so just think of a grid. Whenever support is needed, you are getting power from the car, right? So there is no need to go for extra generation cost, all such things are there. So this is the biggest advantage for the grid. So the thing is that now your vehicle is going to help the grid. Okay, but the thing is that here when you go for a normal charging, this won't work. So here we need to go for a lot of other instances because this is bi-directional power flow. Okay, so when you go for a vehicle to grid to vehicle technology, from the it is simply given a smart grid. From the source, we'll be having a grid to vehicle technology. So power will be going to the charging stations, then to the vehicle. Okay, so that is grid to vehicle technology. On the other hand, when you're going for vehicle to grid technology, the car is power in the battery is taken, it is given to the charging station, through that it is going to the grid. So the power flow is in opposite now. Initially the power from grid is going to the vehicle, now the power from the vehicle is going back to the grid. So now we need to have, in this one you need to have bi-directional, right? That's it. When the grid is when the vehicle is charging, power will flow in one direction, and when it is discharging, power will go in another direction. Okay, so that means that the charging stations should be equipped like this. Where, I mean, not all charging stations. Where you have to go for such kind of technology, then your station should be equipped like this. Only this can work. But the thing is that as it is doubled now, right? Because once it is going up, another time it is going to the grid. So power loss will be more. All such things are there. Okay, infrastructure is needed and power loss will be more. But there is a huge advantage when you go for the grid. Okay. So V2G stands for vehicle to grid technology, enables energy to be pushed back to the power grid from the battery of an electric car. Okay, and this means that you can give it always. So whenever there is a need from the grid, okay, whenever there is peak demand in the grid, at that time only we can supply power to the grid. It doesn't mean that always whenever I want I can supply power to the grid. Okay, only when it can be done only when it is needed. Okay, but the thing is that there are a lot of things will come in your mind when you go for vehicle to grid technology. The first one is that, see, as a owner, okay, I have a car. If I am going for vehicle to grid technology, what is the benefit? Because without benefit, no one will go for all such things, right? Everyone, it's a win-win situation. Eh? If it's a benefit for utility, and should be a benefit for the customer. If there is, because no one is forcing anyone to go for V2G. If it is done, then what is the benefit? That we need to know. Without benefit, because there are a lot of problems we'll face that I'll tell next with this V2G. But without benefit, no one will be ready to give this, right? Let me tell you the problems first, okay? The thing is that I have a car, okay? I'm just taking part in V2G technology. Happy that I gave all the powers back to the grid, okay? But in the very next day, okay, or after 2 to 3 hours, if I have an emergency and I want to drive the car, if there is no power in the battery, then it is a big problem, right? I have used my vehicle. I gave it for V2G technology. They took all the powers from the vehicle. Okay, I'm happy. I'll get a lot of incentives also. That is done. But the thing is that in the very next spin, that is within 1 or 2 hours. Because see, within 1 or 2 hours, I can charge to a maximum value. If I put charge also only less amount of charge will be there, right? So after that, suddenly if I have an emergency, I need to drive my car. Then where I'll go for battery, where I'll go for charging. That is the next one. Anxiety will be there, right? So for that only, they are taking only uh, maximum of minimum of 25% of the battery capacity will be maintained in the battery, will be remaining. Whatever in capacity you are going to give, they will take only up to 25. It doesn't mean that they'll take always up to that. That is up to the user, whichever amount they can give. But they will never take below 25. They'll never make the battery below 25 percentage. Okay, so that means minimum amount of charge is maintained, always maintained in the battery. Whenever you have an emergency, we can use it. Okay, because with 25 percentage, we can drive for long distances. Okay, so this is the first thing which is avoided. Okay, the first thing is that anxiety will be there, that if I give power to the vehicle, power to the grid, if it is an emergency, how I can try. But up to 25% only it is taken. Okay, and it isn't up to the user. I'll show some pictures how users are giving this. Okay, and the next one is the life of the battery. That is very important. Okay, if you take the life of the battery, it depends upon the charging and discharging of a battery. Okay, that means already you have seen, right? The number of times you are charging the battery, number of times you are discharging the battery, that will decide the life. Anyway, a lot of other factors are there, like what is the charging, all such things, the rate in which you are charging. Okay, but let's leave all these things. If you see the time, number of times you are charging and discharging the vehicle, assume that I am not taking part in grid to vehicle to grid technology. Today morning I will charge. When charging is over, okay, again I'll drive for some time. Okay, tomorrow and day after tomorrow I'll drive, and after 2 days again it's fully discharged. Again I'll charge it. That means once in 3 to 4 days I'll have 3 cycles. Right? Today I'm charging. After it is discharging cycle gone now. Next after 2 days I'm charging. That is the thing. Life is maintained. Whereas when I go for V2G technology, today morning I'm charging, I'm going for driving, and I'm coming back, I'm giving it to the vehicle to grid technology. So again, charging is done in the morning and discharging is done in the afternoon. So charging and discharging is done within today and morning and night itself. Again, in the next morning, again I need to charge the vehicle because already charge is done. Right, they have taken the power. Again, charging is done. Again, I'll discharge it. So if this is the case, means you can have frequent charging and discharging as far as the battery is concerned. This will affect the life of the battery. I'll show you a scenario what is there. Okay, so this will affect the life of the battery. And if you see just the vehicle, the battery is the one which is much costlier, right? Around 40 to 50% of the battery cost is for the battery. No one will take a risk on such things, right? So the thing is that the cost, right? The battery cost is there. So if it's like taking a risk now, because charging and discharging is increasing and the left the battery is coming down, means there should be something, some incentive or some help from the grid, right? So one thing is that there is an option that grid will give incentives. They'll help us to maintain the battery. And now there are a lot of other techniques which will control the charging and discharging such that the life of the battery is also maintained. So a lot of solutions are coming up. Whenever a technology is coming into picture, we'll be having a lot of issues. But still, it's a research where lots and lots of new techniques came such that all these things, problems will be eliminated. Okay, I'll just show you here. That means, see, if you go for a single vehicle, this is not advantages. Whereas when you go for n number of vehicles, this is not advantages. Okay, yeah. Can see that the minimum of 25% is always maintained in the vehicle, such that you can use it for the emergency purpose. Okay, and yeah, this is the thing. Okay, and how it is advantages is that I'll just tell you, this is a curve which we have for normal days, right? It's going up and down. Now the vehicles mostly, for example, I'm taking from today morning, early morning, I'm putting it into charge. So when these vehicles are putting it into charge, your graph, instead of having a dip there, all the vehicles are charging, so it will be flat now. Okay. And during the evening, night times, when the demand is higher, okay, so your vehicles will be giving power to the grid. Okay, that means grid, you don't want to generate this much because power is coming from the vehicle itself. So this graph now it became, can see the curve is flat. Okay, so this is what a grid is expecting, and they are getting it from the vehicle itself. Okay, so now see the case where initially we used to have only non-conventional energy sources to supply the power, right? Then a lot of other things came. Then renewable energy sources came, right? Renewable energy sources, because distributed generation is there, through renewable energy sources, grid is getting power, right? Now just think of the condition, another person is also there, vehicle is also there to give power. So just see the condition of the grid. Only normal generation was there, then renewable energy source is giving power to grid. The next one is now vehicle also started giving power to the grid. Okay, so the graph you can see it will be flat, but this is not that much easy, right? See, if I see a grid there, okay, one side a normal power generation is there, another side renewable energy source is giving power, and now vehicle also giving power. Okay, it seems that it is advantage, right? But it's like punching from all the sides, because a lot of issues will be there in the grid, and still it's a research area. Lots and lots of work has to be done. That means certainly if all the vehicles are giving power, how to manage it, right? And some person will come with less power, some person will come with more power. We need to manage all such things. Okay, So it seems like an advantage, but lot of research is needed inside this one. Okay, it's like getting power from all the sides. It's not. Its advantage is too great, but how to manage all the things, how to maintain all the things, that's a big area of work here. Okay. Right. And this one actually, see, this is taken from Nissan Leaf, but it's not from our country. Okay, they can easily see this. How many, for example, this is a power which is given from the vehicle to the grid. You can see here, energy imported to car is this much. Energy exported from the car is this much. So that means how much it is charging, how much it is discharging. Everything is there inside your car. And you can see that at the end of the month, what the thing is that they are taking this much power and they are giving this much power. So what's the difference in that? Only they have to pay that much. Okay, and some incentives will be there. So it's a win. It is a advantages for both utility as well as the user. Okay, so that's how the benefit is. If only benefit is for the utility, means no one will be interested to this. It's a benefit for the user as well as the utility. Okay. And you can see all these things. See, that is why Nissan Leaf, you have a lot of apps to see that how much power you are giving and how much power you are taken. Okay, all those informations will be there inside your vehicle. Okay, and you can see this. This is also in 1 second screen in the top. This is also one thing we have. 1 second. Okay, I just have a screen. Yeah, that means we have seen that. Even though what are things we have, if a user wants to give more power, so it is never possible. The minimum limit is 20. Okay, 25. Below that we can't use it. Okay, below 25 we can't discharge that. Okay, that's the thing. And one thing is that, but he can fix any limit. He can give 30. He can fix to 30. He can fix to 40. He can give to 50. That is up to the user. I just want to give more power to the grid. I want to give only 20% of the power to the grid. That is also possible. Okay, but till only 25 they can go. That limit you need to fix. You can fix it, because with all those things I can fix the limit to 25. Okay, so that is up to the user. So it's advantages for both grid as well as the user. Okay, and at the end of the month you can see these details: how much power is given to the grid, how much you are taken, how much you need to pay. All these informations are there inside this. Okay, so this is vehicle to grid. This is a very big area of work. Okay, but these are things which I told, right, without any advantages will never go into picture. So a lot of incentives will be given to the customers, because grid is getting more and more benefit out of this. Okay, so both will be benefited in this case. Okay, and another thing is the stress on the battery. You can see that there are some papers, journal papers, if you see, they are telling that the life of the battery will be around reduced by 3 years. Due to almost 3 years is reduced, because a lot of charging and discharging is there, so life is reduced at almost 3 years. Okay, but now we have a lot of smart charging schemes. As you have water problems, there are a lot of techniques to overcome this one. Okay, so a lot of new techniques are there by which the life is also maintained. Okay, right. And I'll just tell you one more slide. Okay, once again. Yeah. So if you see as a whole, okay, just what I've seen in electric vehicle, I'll just give a glance on this one. Because if you say electric vehicle, right, this is a very, very huge area of work. You can understand where green and all are coming, right? If you use a normal vehicle with the charging from the grid, it is not advantage. We need to use more and more renewable energy sources, then only it is advantages. And this is the area, one of the area where most of the people can work. All of the researchers have, because if you see the research, right, if you see the electrical engineering research and all, you can see, right, most of the people are now moving towards this one. This is one of the very good area of work. Okay, you can see n number of journals, n number of scholars working in this one. And it doesn't mean that you need to be in a particular stream to work on this. Everyone is having option in this one. Okay, if you see power electronics people, if you see who are all interested in power electronics, right, see a lot of power electronics things are there, a lot of converters are there. Okay, charging, discharging, inverters are there. So lots and lots of options are there for the people who are working in power electronics stream to use here. Okay, and if you're in power system still, because whatever power I'm getting is from the grid and going back is also the grid, right? So power load management, how to change all the load profiles, all these things. So power electronics who are working in power system can also work in this one. Then control, without control nothing is possible in this one, right? So everything is controlled, because it's fully controlled vehicle, all the flow is controlled. So control is much essential. Then communication in which CAN network is using, right? All the things they need to communicate with each other, right? Because when you go for a battery management system, that is the one which is controlling each and everything inside your vehicle. There is a heart of that. vehicle, it needs proper communication from all parts of the vehicle. Battery is down, temperature is high, everything. So communication is important. And when you go for mechanical stream, it's much important. Okay, automobile, that is very important for this one. Those are working chemical engineering, still option is there, because battery, that is the one which is giving power to the vehicle, right? So a lot of scope is there. And another one is there, very important. Those are working in computer. See, there is a if I'm taking the power grid, okay, there was a thing is that initially, okay, the main aim is that I should be able to serve the customers. That is the thing when you go for a power grid. But now the reliability means how to I mean, how the power grid is able to sustain the problem which is from the hackers, because you can write now easily when you go to smart grid and all, it's very easy to hack from outside. Okay, same as that when you go for a vehicle, as far as a normal vehicle is concerned, if it's a definition for safety, then we can tell that the vehicle is safe, and if you have a very good driver, then it is safe. But now when it comes to electric vehicle, the next problem is the cyber issues. Okay, cyber security issues there with electric vehicles now, because it's fully automatic. All these things are controlled. You can, but I'm not going deep into that. People can easily, from somewhere, people can easily start your vehicle and you can make it run. From somewhere, they can easily control your Bluetooth, all such things. They can change all your settings in your vehicle. Okay, they can hack your browser. Simply when you're running, suddenly they can break your vehicle. They can just put your wipers on. Anything is possible inside your vehicle because it's fully connected. Okay. So now cybersecurity issues there with electric vehicles. So there are a lot of options where the people from computer science and all, they need to work on this one. So this is one of the area where lots and lots of stream comes into picture, and this is an interdisciplinary area where everyone can combine and work. Okay, so that is the beauty of the electric vehicle area. Now let me wind up. If you have any queries or anything, now you can unmute yourself and ask, or let me open the chat also. If it is anything, surely I'll reply for that. If we are not able to ask anything here, or if you still need any help in this area, feel free to put a message in my WhatsApp also. Okay. Right now, let me move to the questions. Let me move to the chat. I think I got one question there. 1 second. What is the difference between demand side management and demand response? In general, what we tell is that demand side management is a strategy which is given from the utility, and how the user is responding, that will call it as demand response management. Okay, so demand side management is one strategy which is given from the utility. These are the things we have. Whereas when in general, if you talk demand response management, is a way in which the customer is responding to the strategies. Okay, because there are a lot of strategies we haven't explained in this, and because it's very tough to go for, because DSM is a very big topic, right? I can go for all strategies: load shifting, peak clipping, valley filling, peak shaving, load conservation. A lot of other things are there when you go for demand set management. So all these strategies are given by the utility to the customer, but how the customer is responding to that, that is actually demand response. In response to that, how he is given. Okay.
Hello.
Yes, sir.
The lecture was quite informative. It was very good, excellent, sir. And I have doubt. I have planned to purchase a two-wheeler. You want to purchase a electric vehicle or a petrol-driven two-wheeler? You will advise to purchase, sir.
See, sir, you have a see. As of now, there are a lot of things we need to tell, right? When you're going for a two-wheeler with a in general, if you see all these things, electric vehicle is advantages. But you need to keep in mind that we need to charge it for some, because when you go for electric, when you're driving a two-wheeler, right? I think the only option is to onboard charging now, right? Because as of now, we don't have option to charge from outside, so onboard charging has to be done. And another thing is that if you have proper servicing outside, then it is easy. But in general, we'll be trying to go with electric vehicles now. Okay, rather than going for petrol and diesel. Normally, we used to prefer electric vehicles now. It is advisable now.
What are charging facilities available, sir?
I mean, you're asking as a question, or you're telling that it is available?
Okay, you have said electric vehicle is good, but what about the charging points, different cities for this electric vehicle?
No, when you go for you are talking about the two-wheelers, right, sir?
Yeah.
One thing is that we can charge it from our home itself, right? Two-wheelers.
Our home.
charging option is available, right? You can put a socket and you can charge it. That is why. That's the advantage. See, when you go for the IC engine-based vehicle, the biggest thing is that we need to go exactly to the petrol bunk or something to fill the fuel. But whereas the advantage of electric vehicle is that you can either go to a charging station or you can charge from your home. But when it is from your home, it takes a bit more time because it will be a normally level 1 charging. Okay, it takes a bit more time, but you can charge from your home. You can plug it and you can charge it. That advantage is there.
Sir,
which you can't get it from an IC.
Sir, for charging this vehicle, the normal AC supply of 230 volt is sufficient, or we need to have adaptive sort of.
Yeah, the thing is that, see, they need to follow the standard which we are having, right? Whereas when you go for other countries, it will be different. But whereas when onboard charging, which is there for our country, we can directly plug it and charge it. Okay, because they'll be having a lot of other conversions inside, which is needed for the vehicle. That will be done inside. Whereas it's simply we can plug it and we can charge it. It's enough for us.
Right, sir.
Thank you.
There are a few questions here.
Yeah, let me exploring.
How Indian electricity trade?
Yeah, I'm sorry to say because I think someone is coming back to me. Yeah, but I'm not that much familiar with this energy trading. Okay, if needed, I'll just find the details of this one and I'll give it back. Okay, just put a message to me separately. Okay.
One more question, sir. If we consider cradle and journey to EV, manufacturing, use, and disposal,
is it eco-friendly? Yeah, that is a big question nowadays we have, right? The thing is that as of now, it is eco-friendly. The two things I can tell you. The disposal means mainly we'll talk with respect to the batteries, right? Because that is a biggest thing we have. But nowadays, the thing is that in general, if you're taking an electric vehicle, the battery capacity is very high. So this in case they'll be giving certain lifetime for the battery. But after that, most of the batteries with the technologies now we have, we are not going to dispose it. Okay, because this battery used for your vehicle, there is one thing, but after some days, I mean after the certain period of time like 7 to 8 years, the battery life will get over. It won't be able to supply your, I mean it won't be able to drive your car. But after that, this is used as a secondary power source nowadays. Okay, that means first it will be used in the car, and after that it will be used as a secondary power source like inverters and all, so that there is no need to dispose after that. After some time, you can use it for the secondary power source as for your UPS and all, so that you can still use your battery. Okay. So for the next around 10 to 12 years of time, you don't want to worry about that, because first it's used for your car, and after that it is used for your secondary power. But after that, disposal of it is a big problem, because when lots and lots of EVs are coming into picture, then lots and lots of batteries will come. So after that, surely there'll be a problem with disposal of all such things. But as of now, initially what the thing is that after life of the battery, it has to be disposed. But now with the technology we have, we'll be using as a primary source in our vehicle, either car or whatever you have. After that, you can use the same battery as a secondary source for supplying power to the house or anywhere it is needed. Okay, but it's eco-friendly. It's there.
Another question, sir.
Dr. Sujit, one question actually might not be related to your presentation. Actually, for last 2-3 days, we have heard that government is going to introduce ethanol and trying to make a blend with the existing petrol. So my question is like, if the government is intentionally going for like conversion or for addition of ethanol in petrol, then don't you feel that the electric vehicle or the electric mobility will be means a question of what we are expecting to get it on Indian roads in 2-3 years, but now I think it will take decades to be implemented fully in India.
I mean, in electric vehicle, right? So one thing is that, yeah, there's a scope for adding ethanol into petrol, and I think, but not 100%, right? Around 10-20%, it will see some grade 10, grade 30 and all are there. Yeah, that is there. But the thing is that as far as electric vehicle is concerned, but that is with respect to fuel, that may be advantages. Whereas the other advantages of electric vehicles, you won't get with that, right, sir? Another thing is that...
Because sir, actually the question that always comes up now, like what about the infrastructure of the automobile vehicles on the road? Like we can't actually just straight away switch from the existing IC engine based engines or vehicles to electric vehicles. So we need to have like a bridge between both the the technologies, right?
Yes, sir. It's understandable. The thing is that suddenly we can't go for a huge transformation. As far as a country like India, it's very tough to go for a sudden transformation from this one to next time. That is why I think by 2030 they are just aimed only for 30% of the vehicles running on the road. But still, it needs a lot of infrastructure because charging stations has to be implemented. Okay, and it's very simple to tell that we need to go for large charging stations. But the infrastructure with respect to the transformer, with respect to the lines, with respect to the grid, all such things has to be improved if you want to go for at least 30% of the vehicles. So a lot of changes in infrastructure is needed for going for this one. But it will be a slow transformation. It doesn't mean that within 2 to 3 years we'll directly go this one. It will take at least a minimum 5 to 6 years. Yes, it will be slowly moving into this transformation. And one more thing is that as of initially what we had is that there is an option that they are going to build a new charging station everywhere. But now we can see probably around 4 to 5 months back, there is something that the same Indian Oil Corporation petrol bunks, they are going to install the EV infrastructure. It's not a new thing which is going to existing petrol bunks itself. They are going to have a EV charging infrastructure. So slowly they'll be moving into this transformation. I can surely tell that it is not a rapid one. Within 5 to 6 years, nothing is going to happen. Slowly it will change. Probably after 8 to 10 years, we can see that slowly all these vehicles are replaced by electric vehicles. As far as a country like India is concerned, it's very tough to go for sudden change.
And also, sir, actually the cost of the vehicle. Actually, I was also looking for electric vehicle because some vehicle, but the cost of the vehicle is so much that at least you can buy a luxurious car at the present cost. The cost of the
Yes,
vehicle
sir.
is a concern.
Yes, sir, it's understood. But two things are there. One is that with respect to the number of vehicles, because now it's very less, right? Less number of EVs are running on the road, so initial cost may be high. But it's understood that when after some time, as the number of vehicles in the roads are increasing, the cost of vehicle will come down. Because only less number of vehicles are moving, so obviously the cost will be very high. But when after some time, when around 10 or 20% of the vehicles are running on the road, it is expected that the cost will come down. And one more thing we have is when you see that battery swapping technology is which is there already coming into picture, there is an option that vehicle will come without battery. Okay, so that means as you have seen, right, 40 to 50% of the cost of the vehicle is only for the battery. If that is implemented, 50% of the cost of the vehicle will come down. That is why we have seen as of now the initial cost of electric vehicle is higher, but
Yes,
after some time, when more number of vehicles are coming.
Yes, actually the cost actually depend upon the mass of production. If the production rate or the mass of production is more, then obviously the cost will reduce. But it will take
Yeah,
some time. Actually, my personal feeling is it will take some time. The concepts are very good.
yes, sir.
The concepts are good,
It
but
will.
it is like the practicality, or we can know the feasibility in Indian roads. That's the issues.
Yes, sir. It takes time as far as India is. And one more thing we have seen about V2G technology, vehicle to grid. It is implemented in other countries, whereas we, as of now, we don't have even variable. I mean, time of the data. So if you want to go for V2 grid technology, also we need to have V2G. I mean, time of the use tariff. Then if I want to get it, then I need to go for changing the metering infrastructure. So everything has to be upgraded if you want to go for all these technologies. But it is there in other countries, but it will take bit time for us to implement this.
Right, sir. Right. Thank you, sir. Thank you for a wonderful feedback, sir.
Thank you.
Sir, another question. What is the
Yes,
life
I'm
of
scrolling.
battery in electric car? Life of battery, sir.
Yeah, it's a big one, right? One problem of battery swapping I've heard is that the swap battery to be provided may not be up to the mark. It is like changing a new one for a old used one anyway to track the product. See, this is what I told. It depends upon the usage, how we are using the battery. Whatever battery I'm giving, I may get something different. Okay, so it's in the initial stage now. I'm sure that after some time, you'll be getting a lot of options to track all these things, which battery you have used, right? As of now, just go and exchange. Surely it is understood that someone can use a vehicle in a different way, someone can drive in a smoother way, someone can maintain the battery better way. All such things are there. When you're getting another battery to the car, it won't be any vehicle, it won't be up to your expectations, right? But as of now, it is an initial stage, but surely after some time, all this will be sorted out. A lot of techniques may come into picture. That's expected. Okay, but everything in the starting, surely we have a lot of issues like this. Even this is not the only issue. After some time, when lithium-ion battery is replaced by all other batteries, then they need to have different type of batteries. A lot of problems as expected. But I think that a lot of research is going in this area such that all these issues will be sorted out.
Thank you, sir.
Next question, sir. In India, why the domestic customers are not
Is
encouraged to
to
consume?
consume. You're telling about India. Okay. The thing is that when as of now we don't have that option with the time of the day tariff. Okay, but still now it is implemented to HV installations that with respect to the time of the tariff they can use it, but it is expected that soon it will come to domestic customers also. As of now, it is not available, but once it is coming, then they are encouraged to use, because see, if you know the tariff, then only we can understand that see, the best way they can do is that when the demand is higher, automatically they will shut the loads. That's what they do. But when the time of the tariff comes into picture, user can understand that the tariff is very high, and we can shut the load by themselves such that it's benefit for both. Okay. So as of now, since the time of the tariff is not available to the customers, we are not in a position to know what is the peak demand time and what is the tariff. Once it is known to the customers, then only we can make use of that. So as of now, we don't have it, but it's expected that it will come to domestic customers also. As of now, it's for HP installations. Soon it will come for customers also. It's there in other countries now.
One more question, sir, about the longer life, whether EV or ICE vehicles have a longer life.
Yes, if you compare EV and IC vehicles, which have longer life, if you see in general, I'm not much into that, but if you see in general, the maintenance, repair, and the number of parts in a vehicle, see, if I'm taking an IC engine based vehicle, if you see, I mean, sorry, if I'm taking a motor, you have electric motors, right, which is highly efficient. Then there are power electronic converters, right? And they're highly efficient. So in general, as an electrical engineer, if I'm telling, these will have, but when you go for mechanical parts or automobile, that is different. But whereas with the motor and with the motor, the maintenance required for that, with the power converter, I'm using all this. It just understood that this electric vehicle have more life compared to IC engine based. It is only with respect to the electrical part I can tell. Whereas if you see the mechanical parts and all, I'm not that much aware. But with respect to the electrical part, I can tell that this is having more life than that.
But the maintenance will be, but maintenance cost will be high, na sir? Electric vehicles.
Cost? Please, sir.
Repair and maintenance of the cost will be high for electric vehicle than your mechanical vehicle.
The number of parts is very less, sir. Okay, so maintenance cost, and as far as an electric motor is concerned, it gets very, very less maintenance compared to IC engine has n number of parts. So it needs, see, just for if I'm taking a vehicle to a service station, after some time, if they give a bill, then I can understand these many components were in my IC engine vehicles and these many things are changed. Whereas when you go for electric vehicle, there is not much parts there, only a motor, converter, and a source. That's it. So the maintenance is very, very less when you go for electric vehicles. Okay. So that is the advantage. That's one of the advantage.
Thank you. Thank you.
What are the government initiatives for the implementation of EV and EV infrastructure? As of now, what they are going to do is that they are going to a lot of charging infrastructure is going to come. Okay, and in each petrol bunks they are going to implement charging stations, and they are giving, as of now, they are giving a lot of incentives when you go for EVs. Okay, when you want to purchase incentives, they are giving. I mean, sorry, when you want to purchase EVs, they are giving a lot of incentives also. Okay, they are trying to promote it. And that's why a lot of the manufacturers, they are going from IC to EVs now. Okay, so a lot of support is there from the government for EVs. And I'm not sure if you see tax also. There is some tax subsidy when you file tax when you have EV also. I'm not sure, since I'm not warning when I have seen to that. But there is an option in tax also if you have EVs.
So we have the last question, that is, sir, please say the solution to power shortage by plenty
Use of electric vehicles. So that is what we are saying. As you go for more and more electric vehicles, they have to be charged, right? So we'll be having a lot of problems with the charging. So a lot of infrastructure has to be changed. Okay, that means. But the thing is that two options are there. One is that if you go for electric vehicle also, the charging from the grid is not much advantageous, because again the same fossil fuel is going to come in picture. So we need to go for renewable energies for charging the electric vehicles. That will give you all the advantages of the electric vehicle as well as the fuels. Okay, but as of now, but the thing is that we can't tell that all vehicles will be coming into picture 2 to 3 days, right? We have enough time to put a lot of infrastructure, because if I'm going to put a charging station, right, new charging station means again the transformer near that the capacity has to be increased, right? So surely we need to increase the infrastructure if you want to go for electric vehicles. Okay, and nowadays they are planning to go for more and more renewable energies to charge the electric vehicles, such that the dependency on the grid will be reduced and the load on the grid also will be reduced.
Okay, I think we have come to the end of the queries. If anyone have any queries, or you can unmute yourself and ask her or else we will conclude the session.
Last question is there, but so let me tell you, if you need any help or if any information needed, you can put a message in my WhatsApp. But I've seen one more question, the last one. Is there any software? See, as of now, we are doing again same V2G and G2V. We are just doing it in MATLAB, okay, as of now. But there are a few other PLECS, some other software is also there. Let me check it out because I'm not using that software. We are using only MATLAB for this one. But still, let me find any other software is there, and I'll give you the information. You can put a message to me. I'll just take the information of the other softwares and I'll give it to you. But as of now, what we are using is only MATLAB for that. But still, a lot of other softwares are there also. Okay.
Okay, thank you, sir. Thank you for this such an interesting and wonderful session. Starting from scratch, we could know about electric vehicles to the advanced level of research that has been going on nowadays. And I think I wish you a happy day. And